All right. And this is an area of mathematics that's part of statistics, but it's also an area of mathematics, as somebody identified before, that comes up in areas like psychology, healthcare, business, something that's very transferable in lots of different industries. I think of my friend Nick, who last night was working a double shift at Flinders Medical Centre. He's a nurse there. He would be using aspects of this in his work when he takes like blood measurements from people, knowing where their health is compared to the baseline of what's expected for somebody of their age. You know, so this type of topic is used in lots of different things. All right? So we're going to learn about today. It's called the normal distribution. So many data sets have frequency distributions that are bell-shaped. Can you underline bell-shaped? And symmetrical. Can you underline symmetrical? About the mean. What does symmetrical mean? Equal on both sides. What's something that's symmetrical? Give me an object. Often your faces, often our faces aren't quite symmetrical, are they? Something symmetrical means you split it down the middle, it's the same on both sides. What does bell-shaped mean?
Shaped like a bell.
Shaped like a bell, right? Ding ding. Okay, so you've got some examples on your sheet there. Chest size of Australian males, length of male tiger sharks, height of Australian females, lengths of males manufactured. Big data sets often have frequency distributions that are bell-shaped. Okay. Generally, for a distribution to be normally distributed, it needs to have a lot of data. Okay? So, here's our rule. For any measured variable from any population that's normally distributed with mean, mu, and standard deviation, 68% of the population will lie between, now what does this mean? Mean minus sigma, standard deviation, and mean plus standard deviation. So what does that mean? It means 68% of the population lies within one standard deviation. Okay. Approximately 95% of the population will lie between two standard deviations. And lastly, approximately 99.7% of the population will lie between three standard deviations. Okay? So, visually, to show this visually, here we have our normal distribution curve. This here is our model. Right? This here is what the normal distribution is. We could put an arrow here on your sheet and you could call this the normal distribution model. Okay? Let's start with the middle of this model. The middle of the model is that symbol there, which stands for what? It's the mean. Okay, so the mean is in the middle. Then we've got mean plus standard deviation. So this is plus 1 standard deviation, plus 2 standard deviations, plus 3, minus 1, minus 2, minus 3. So between each of these increments, between the mean and 1 standard deviation up, we expect there to be 34.13% of the data. That's what we expect. Likewise, subtracting 1, we suspect 34.13%. Okay? Showing where the data lies. It's very rare for there to be something more than 3 standard deviations above the mean. It's not saying that it's not possible, it's just that it's rare. Okay? You can see this curve, notice that the curve never touches the axis. Because this actually goes on for infinity. It goes on forever. Okay? Likewise, it never touches the axis here, it goes on for negative infinity. Okay? let's just pick one of these up here. Let's just go the height of Australian females, okay? So say we're picking an age, 17-year-old Australian females. There's probably an average height of Australian females who are 17 years old. There would be people who are slightly taller than the average. Some people who are very taller than the average. And some people who, for some reason, are extremely taller than the average, way more than 3 standard deviations. Likewise, the inverse is also true, isn't it? But most people are around that average. Now, standard deviation, let's talk about what mean and standard deviation are all about. What does the mean of a data set mean? The average. How do you work out the average of a data set? Yeah, you add everything up, you divide it by the number. Standard deviation. What does standard deviation of a data set mean? Yeah.
It's how much the results are deviated from the mean.
Great. She said how much the results deviate from the mean. Standard deviation is about the variability of the data. Right? How much variation there is in the data. Okay. So if we were to talk about the average age of this class right now, and we talked about the standard deviation of that average, all right, then let's say that I decided to instead work out the average age of everybody at lunchtime on the oval and work out the standard deviation of everyone on the oval. Which standard deviation or which average is probably going to be more consistent? Which one's going to be more? This class. Why is this class going to be more consistent? Everyone's similar ages. On the oval, are people more like varied ages? Yeah. So if they're more varied ages, something that's more variable has a higher standard deviation. Okay? If something's very consistent, it means that if a data set is very consistent, it's got a low standard deviation. Right. So, standard deviation, we can write that down. Let's write down what standard deviation means. I really liked your definition. Can you repeat what you said? Yeah.
It's with the amount that's deviated from the mean.
Yeah. The deviation of the data set from the mean. Or another way of saying it's the variability. It's helpful for us to know this. Low standard deviation, high standard deviation. What's the difference between these two? What's the difference between a low standard deviation data set and a high standard deviation data set? Which one's more consistent? Low, yeah. So more consistent data. Are you writing down these notes?
Yeah.
Yes.
What could we write next to high standard deviation?
Less consistent.
Less consistency? What's the opposite of less consistency? Like what's another way of saying less consistency? If it's less consistency, there's more variability. Yeah. All right, more variability. All right. Are we ready for the next slide? So like a sports coach may use standard deviation as a way of like comparing the consistency of a team's performance on some sort of data metric from one game compared to another. That's another way that this is used. Heaps of work in that area if you want to go down the line of like sports science, statistics. A friend of mine worked as a statistician operator at the basketball. So he gets paid to sit and just like enter statistics at the basketball. Yeah.
The one above the low one. That one. What's the last word to say?
Data. Data.
can't even see it.
Permission to erase?
Yes.
Permission to erase? Alright,
You forgot the main down the bottom.
thank you. Thank you. Alright, what does this graph, the normal distribution, show us? It shows us that our data, shows us data that is normally distributed. Normally distributed. The graph is blank shaped and blank.
Bell. And symmetrical.
Bell shaped and symmetrical, well done. The middle bolded line, mu, is the mean. Good. Sigma is the standard deviation. All right. So these values mean what percentage falls between one standard deviation of the data? 34.1 is just above the mean,
68.
so you've got to add them both together. 68.26%. Right?
95.
Let's go with approximates here. Let's go approximately 68%. Approximately 95% falls within two standard deviations.
And that's 99.7.
Yeah, good.
Okay.
And approximately 99.7% falls within three standard deviations. Okay. We've got 3 blanks left. The percentages on the graph show the what between each line. It's a short word. Distance, close to distance. I was looking for
Area.
area, is what I was looking for. Yeah. Altogether, the graph makes up what?
100%.
100%? 100%? 50% on one side of the lane, 50% on the other. Let's say these answers on the awkward pause after 3. The first answer is, I want you to tell me what mu stands for. 1, 2, 3. Oh, let's try that again. 1, 2, 3. Good. And what does the sigma stand for? 1, 2, 3.
Standard deviation.
Nice. Are we ready to turn over? Question.
Can it be 100% if it never means yes?
Oh, great question. So, yeah, the model assumes, because eventually that, like, it technically would go on and on and on, wouldn't it? But it's, I guess, rounded to 100%.
It's not accurate.
Yeah, it's not, like, if it does go on for infinity, then it does keep, yeah, I agree, yeah. Permission to go to the next slide? Okay.
Yeah, I'm gonna get all of them.
Okay, 10 seconds for you to read the introductory blurb to this question silently.
Yeah, so now I've got all written down.
All right, what are the key things for us to highlight from the first introductory sentence? Mean of 4.5. What else? Good. And what's the other key piece of information?
Normally distributed.
Good, the fact that we know that it's normally distributed, okay? Because we know it's normally distributed, let's look at the question. Show the above information on the graph below. Show the percentages, label the axis. Alright, so because it's normally distributed, this is where you might have to flip back and forward, between the page. Let's start with the mean. What's going to go at the bottom of the mean?
4.5.
4.5. Let's label the axis length of nail. Alright, the mean is 4.5, the standard deviation is 0.1 centimetres. So how do I label these other sections? What do I plus?
Standard deviation.
0.1. Which way, if I'm going to the right, I'm going to add the, yeah. And then if we're doing to the left, we need to take away. Okay. Now we need to show the percentages. 34.13%. It's the same as on the previous page. Now, Molly, question is, I've got these 4 percentages here. Tell me about how I then write the percentages on the other side.
You like mirror it.
Mirror it, good.
Thank you. Thanks, man.
Right, let's keep going with the question. Let's keep it punchy here. Find the percentage of nails with measurements between 4.4 and 4.6 centimetres.
68.26.
How did you get that?
Plus
You just plus them together. This plus this. Oops, I forgot to put centimetres there. What about between 4.2 and 4.3? We just look here. Good, 2.15%.
Good job, Carla.
Alright, I'll give you. Let's keep going together. We'll keep going together. Permission to go to the next slide? Granted? Granted?
No, that's not video now.
So, question C. Oh, I could have gone here. If a machine manufactures 3,000 nails in one day, underline 3,000 nails, how many would be expected to be between 4.4 and 4.6 centimetres?
68.6.
Well, we know it's 68%. 68.26%. But we know that there's 3,000 nails. So we know that it's going to be 68.26% of 3,000. Now, how do we work out a percentage calculation? Of, what does of mean in maths? Times. 68.26. How do we work that out as a, what do we need to convert it to?
You just put the 6
You need to put it as a decimal, right? 68.26% is 0.6826. How did I convert my percentage into a decimal? Divide by 100. You move the decimal spot 2 spots to the left. Okay. 0.6826 times 3,000. Can someone use their calculator? Type it in. Give us an answer. Have you got an answer?
You have to round.
What was the answer?
2048.
Can you give it to me as a decimal first? Just so we can talk about that. What is that as a decimal first? 2047.8. Okay, good, thank you. I just didn't hear it because I've grown up playing guitar until I have hearing loss. loss. Now, class, listen carefully at this point.
Boys, it's just me understanding.
Okay, class. Okay, 2047.8. This variable that we're dealing with here, you can't have 0.8 of a nail. We kind of can, but we really need to round this. So we would round that to 2048 nails. Now,
You're just making.
No, yeah, you would have to round it down because you're making more nails. You're just imagining like how other people do the nails.
Creating this extra 0.2.
alright, so I'm happy to write 2047 or 2048 nails. Okay?
Wait, why would it be or?
Okay, if we're looking particularly at the model, you would need to probably round down in this case. Because it doesn't fit, the 2048 doesn't fit within it.
Yeah.
Alright? In the test or the exam, in that type of question, they'd be looking for you to round to a whole number. Okay?
It's ridiculous.
Tell us why it's ridiculous!
Well, you can just take some
Just cut the nail.
Alright.
Just take the nail.
Next question. Thanks for that comment. We'll take the feedback on board. 4.2 and 4.3. Comment of the day, Kyla. That's ridiculous.
Comment of the day.
Now, what was this one? 2.15%?
Yeah.
Okay? 2.15% of 3,000. How do I convert 2.15% to a decimal? Same way. We move the decimal spot. How many spots? 2 places to the left.
Nice one.
So it's 0.0215. 0.0215.
Yes, it is. No, it's not because you just said 21.
Yeah. If your answer is 600 and something, you've forgotten to move it. Is it about 60?
Yeah, 64.
What is it? 60?
64.5. Oh, 64. Yeah, wait, that's what I said.
You can have
I would accept 64 or 65 now. Yep.
In the test, do you want us to give you both the options?
When you give me one of them, yeah, just give me one.
But either step or.
In this question, I think either of those would be acceptable.
Or you can
Yeah.
just.
What about the exam?
Yeah, you just get both colours.
Okay, yeah, in the exam, that type of question, they would accept both of those answers. They accept both. Yeah. Good. As long as it's rounded, yeah.
Not mine,
One size fits all.
Shh, let's focus back in. The last question before it's time for you to do some questions by yourself. How reasonable would it be to have a nail manufactured greater than 4.8 centimeters?
It's a bit of a silly question.
It is reasonable
Why is it? Tell me why.
because there are nails that are greater than 4.8.
But what, how reasonable, how likely is it? Very likely or? Now, can anyone give me some maths to back up their response?
3.9 nails in that range.
Is it, also you worked that out? Yeah, okay. So, now, I've lost my first page. So let's go to your 4.8 is up here, class. Above 4.8, there's 0.13%. So there's some chance of it being there, but it's very unlikely.
It's a machine.
So,
I didn't read. I was like, this is small. That's a machine manufacturing thing. Well, yeah, that would be. Yeah.
okay, very unlikely, only 0.13% of nails are expected to be more than 4.8 centimeters. It's still possible, it's just maybe unlikely. Remember, amidst all of these things, the normal distribution is a model, Alright? There are going to be times where there's results that are either a lot higher or a lot lower than to be expected. And that's very normal. What we are going to do today is we're now going to get into some questions for you to be able to have a go at these together by yourself.